Hello everyone. We are going to work this week through a series of functions in R that will allow us to view data. If you remember, one of the primary steps in the data mining model is we load up our data, we actually acquire our data, and then we actually have to visualize our data. And we have to look at what we're looking at or understand what we're looking at so that we can determine the best path forward when it comes to actually analyzing the data. So one of the first things we're going to do is we're going to actually load the data up and use various plots to sort of understand how the fields look and how they interact with one another. And that's kind of what we're going to focus on this week. So the first thing we're going to do is we're going to load a file. I have given you a file called bostonhousing.csv, and it's a comma-separated variables file, and just like the one we had before. You want to make sure that it's in your working directory. So if you don't know what your working directory is, remember the command for finding out your working directory is getwd, get working directory, with the open and close parentheses with nothing in between them. So it's just going to show you what your working directory is. If you already know what your working directory is, go ahead and drop that bostonhousing.csv file into that directory. Or if you want to put it somewhere else on your PC, just be prepared to be able to provide the full path name to that location when you get ready to load the file. So we're going to load it into housing.df. That's going to be the name of our data frame. Similar to like the last time we did this, we just come up with a data frame name that's actually representative of what the data are. So housing.df is set equal to the results of read.csv. There's our file name, housing, our bostonhousing.csv, in quotes, because it is a file name. And then we also specify that header equals true so that the file, we indicate that the file actually does have a header where there are column names. Little tip. You can drop the header equals true on read.csv because that's the default. So from here on out, you only have to specify any information about the header if in fact the file you're working with does not have a header. So we can just do read.csv, bostonhousing.csv, and that's all good. So we're going to go ahead and load that file. Now, in order to do that, I am going to pop over to R, and I have brought up R, and this is what it looks like, of course, when it starts. Now, there's a lot of commands that we're going to be working with in this session, so I decided to put those into a script. And that is the script I have called viewing data. So I called it viewing data, and when I bring up my script, it allows me to see all of the commands that I have that we're going to be working with in this session. What I did to do that is I decided I wanted to save all of my work, and so I went into File and I said New Script, and it opened up a new script for me where I could write all this. It's just like a little editor. You could write all your commands directly into that script. Then when you get ready to run that, and I'll show you how we do this, you can go into the file, and our first command there is to load the data file. Housing.df is set equal to the results of read.csv, bostonhousing.csv, header equals true. There's a couple ways you can do this. You can run everything all at once, which is like you would normally run a program, or you can run it one command at a time. And so what I'm going to do is I'm going to run it one command at a time because I want to walk you through each one of these commands and explain what each one does. So the first one you'll see is # load the data file. Anytime you see a # in an R script, it is a comment. R will ignore it. So I will go ahead and run that, and it shows me that it ran the comment. And it moves my cursor down to housing.df. So I'll go to that middle run one line at a time command and hit that, and it loads my file. So I have correctly loaded the housing file into a data frame called housing.df. Okay. The next thing I'm going to do is I'm going to go check it out. I want to see what's going on in that file. So bypass my command and view the data. And there's my view, right? So it tells me, or shows me, that I have, actually if I count these up, there are 14 columns and there are 506 records. I could do a dimension command in R and that would give me the same information. So anyway, now we have the file loaded. So we're ready to move on. Now we want to check it and we want to see if there are any outliers. And that's part of the process of viewing the data. Remember, we get the data and we want to look at it first to see if there's anything that's really kind of goofy with it. So are there outliers? Is there data that is missing? Is there information about the records in this file that we really need to know in order to be able to do a good level of data mining and analysis on it? So there are a series of tools. there are actually many, many tools, many more than we cover in this session, but there are a series of tools that we can use to take a look at the data that is in the file. Well, we've already done view. So we can use view, and it shows us all of the records and all of the columns, everything that's in the file, but it's kind of hard to really look through that. Now, our file only has 506 records in it, but imagine if it had 506,000 records in it. It would be impossible to use view for that. So we would need to have some other tool. We're going to look at things other than view. For example, we're going to look at a line plot. We could use a line plot, which is the ability to track a single variable over time. And that could be like, for example, like the stock market is a great example of line charts. Tracking a stock price of a company from the last 6 months is going to give you a line chart, and that's a great example. We don't tend to use those as much in comparison for data sets, but there might be cause for us to use that. Scatterplot, though, is very useful. And scatterplot allows us to look at one variable, against another variable. So we can look at two variables at a time. In more advanced scatterplots, you can look at three-dimensional space and have three variables at a time, but we're not going to do that today. Only two variables, and often that's enough. We can build a scatterplot, and it allows us to see the two values for each record and how they compare. Here's an example line chart, and again, the stock price. I used the stock price example, and there's a stock price example for you to see kind of how we track that over the last 60 days. And here's a scatterplot. The scatterplot, this one's a simple scatterplot where we're actually comparing miles per gallon for cars against the weight of the car. And we see that there's a negative relationship in that, so that the miles per gallon is higher when the weight of the car is lower. And that would probably come up with a negative correlation if we actually calculated that correlation coefficient. But you're starting to see how you can use a scatter plot to be able to compare different variables and determine some information about those variables. In this example, we were able to determine that there's probably a pretty good negative correlation between miles per gallon and weight of a car. So, values can be done. Like I said, we can do almost all of the stuff we're going to do today, we can do in Excel. And you just go into the insert option. Once your data are loaded in Excel, you go into the insert option, and you can insert a plot. Or we can do it in R, and I'm going to show you the code for each of those. But just keep in mind there are countless other applications that have their advantages and disadvantages that will allow you to visualize data. So let's talk about a couple things in R that you're going to need to know. Okay, one of the things is packages. When you load R on your computer, you're loading what's called base R. And base R has a number of functions built into it that you can use for a number of different things. But R is constantly being updated, and it's constantly being expanded. It's open source. And people are writing what are called packages. And packages can be acquired from various mirrors around the planet, and you can download those packages onto your PC, and then you can invoke those packages by using the library command. So we're going to have to do that actually, because some of the functions that we want to use today are not part of base R. So we're going to have to go out and get packages, and we're going to have to download those packages to our PC so that we can actually see what we can do with the functionality that's built into them. Okay. So a little bit more about packages. We can install the package that we need. We only have to do that once on each PC. So once it's installed on your PC, you have all that functionality, you have those functions, that's all there. You do have to, however, each time you need to use it in a script, you have to use the library command. And what the library command does is it goes out and it gets all the functions that are part of that package, and it brings them into your R environment so that you now have access to those functions. So you'll have to do that each time, but that's not a huge deal. It's not terribly taxing. There are a ton of packages out there. There are people writing packages all the time. And there are packages to do things like load Excel files, or actually open and interact directly with an Excel file so that you can update the data that's actually in an Excel spreadsheet from R. There's packages to do pretty much anything you can imagine. So when you go out to look at the list of packages, you can probably be a little overwhelmed with the number of packages that you need. So it's probably going to be important for you to really understand what you're looking for. A couple packages that we have referred to, or we will refer to, is things like Lattice. Lattice is a style of plot. It's a package that allows you to have access to a number of different ways of doing plots. ggplot2 is one we will use today. gplots is another one we'll use. Reshape is another package, or one of many, many others. Now, a couple different ways to install packages. There is a function called install.packages that will allow you to specify a package name, and it will go out and ask you maybe a couple of questions about which mirror you want to use, and then it will say, okay, here's your package, and it will download code. And you'll see it actually downloading that code to your PC. An easier way to do this is to actually just install the packages from the R window. There's on the main menu, there's an option to install packages, and I'll show you that right now. Okay, I'm going to close this down. I don't need this. Okay. Up here, packages. Hit packages, pull down to install packages. The first thing it's going to ask you to do, see it says, please select a crayon mirror for use in this session. And it's just basically, there are mirrors all over the world. And I just use the USA California one because it seems to be geographically closest to us. And there's Oregon now, it just doesn't really matter. So I click OK on that. And then it says, okay, now tell me what package it is you want to install. And it is doing that, I promise. Okay, and here is the list of packages. And like I said, there are a ton of them, right? So you will probably know what you're looking for before you come out here to search for it, because there's really no information about any of these. But one of the ones we're using is ggplot, and we can find that in the G's, because they're all in alphabetical order. And it's here somewhere. ggplot. Oop. There's ggplot 2. That was one of the ones we were going to use. So we can go ahead and hit that and hit OK. And I'm probably going to get an error message because I already have it installed. So it may not do really anything. If you don't have it installed, though, you will see that there is a bit of code that comes up that actually shows you that it's downloading that package, and it's downloading it to your PC and installing it on your PC. Okay. Going back to the slides. Okay, so now we can build our plots because we have all of the functionality in the packages. All the functions are there, and we will probably have to do a library command or two in order to invoke those and make those available. But we're ready to build plots. But before we do that, there's a couple things I want to make sure that we're clear on. I think I went over some of these in the previous presentation, but I want to just go over them again. Okay, so there's some new R functionality that can help you build what you want. I already talked to you about saving commands to a script. So in the past, what we've done is we've just gone into the console and we type a command directly onto the console, and then we can hit return and it will do whatever it is we want. But once we do that, it's gone, it's done. And we may want to, and we are going to want to, shortly be able to build scripts that we can save and rerun each time. And that's what I showed you when we went into R. And I was able to go and File, Open Script, and bring this script up. See, these are all the commands that we're using today. Or I could do File, New Script, and it will give me a new editor, and I can just type my new commands in there. When you run them, they actually run on the console, but you can actually save them. So that's something that will help you a lot. The other thing that will help you a lot, and this is actually downloading this package, which is why I don't have control over my console at the moment, but is a serious time-saving tip. And I call it a serious time-saving tip, and I'll show it to you once I get access back to my console. But the serious time-saving tip is that you can type a command in. Sometimes these commands can be pretty long, and as you know, R is very picky about its syntax, and maybe you mess something up. You use a pound sign where you should use a dollar sign or something like that. So that can be very aggravating when you get to the end of a fairly long command and you realize you messed it up and it doesn't work. So you got to type the whole thing all over again. Well, you don't. If you hit up arrow, it will bring back that command and allow you to edit it. So you can go back and you can change what you messed up and fix it and rerun it again. So that's actually really nice to be able to do that. And the other thing I wanted to show you is making sure that you know how to access variable names once we have loaded a data file. So typically that's done using the dollar separator. And with the dollar separator, we can specify our data frame, so housing.df, with a dollar sign, and then a dollar sign followed by the variable name. And that will allow us to access a single column in a file. We can also do it using sort of the square brackets where we indicate that we want like column 1 or column 2 and row 54 and 55, whatever. So there's all that functionality that you learned in your data camp modules. But this is actually turning out to be probably the easiest way to access a single variable, and it allows you to access all values for a single variable when you're building your plots. So we're going to do that a lot. So I want to make sure you're clear on that we are going to be able to specify housing.df. And when we specify housing.df, we're going to be able to go ahead and indicate which of the variables we want. Okay, now we're ready to build the plots. So we're going to go ahead and do that. We're going to skip line plot for now, and we're just going to we'll jump directly to scatter plot. So housing data. We run a dimension on housing data, find out we have 14 variables and 506 rows. Okay, great. We already knew that. Okay, so it's going to show us various conditions about each of 506. That's what this data file is. It's share various conditions about each of 506 houses in the Boston area, in the Boston market. So we know that they're around Boston. We also know that some of them are close to the Charles River and some of them are not so close to the Charles River. But this is going to show us things like median value and crime rate and percentage of lower status and how much industry land or non-commercial retail land is around the houses. Just give you a feel for what conditions are like around each one of these houses. Okay. Some of the categories are, some of the variables that we have are categorical. And I think you probably remember this from your statistics class, but I'm going to go ahead and go through it again. A categorical variable is a variable that fits into a limited number of categories. So it could be male, female. It could be rent or own. It could be, short, medium, or large. It could be something like that. And it just means that the variable is one of a limited number of values. So in the Charles River, in the Boston housing data, there's a variable indicating proximity to the Charles River, and that is a categorical variable in the sense that if you're close, it's set to one value, and if you're distant, it's set to another value. So there's only two values, possible values, categorical values that show categories. Those categorical values can either be nominal or they can be ordinal. Nominal means there's no order to them. It's basically you're running through your categories, and there's no one category that's higher than the other. Ordinal is in order. It means, like, for example, small, medium, large. That could be considered to be an ordinal categorical variable. Or if there are some numerical values, for example, it could be high 1, 3, 5 or something like that, and some meaning is applied to those actual numbers. That would be an ordinal variable. Many of the other variables, though, are numerical or they're quantitative, and being numerical or quantitative, these are just numerical variables. Some of them can be continuous and some of them can be discrete. Continuous means basically that there's any value between one value and another is good. It can be an integer, it can be a decimal, it can be whatever. So between 1 and 100, you could have 79.58 being a valid value for that particular variable. Discrete is typically looking at values that are whole numbers. So it would be, in our example of 0 to 100, we would only have 100 possible values because there's only 100 possible whole numbers that would fit there. So anyway, just a little bit about those variables. Not really relevant too much to us, but just keep in mind that we are going to be looking at variables from different perspectives. So we are going to now plot out median value versus the percentage of lower status people that live in a particular area. So the variables in our data file are median value, MEDV, and LSTAT. And they are already in our file, so they're already loaded up in our data frame. So we can do a couple things. The simplest way to plot this is just to use the base R command plot, just like I have it here. So you would put plot, housing.df is your data frame, followed by specification of a variable, which is your median value, and the little tilde means that you're plotting against another variable, or you're comparing against another variable. In that particular case, you're looking at housing.df against same data frame, followed by a $sign, which and your variable name, which is LSTAT. Okay, that works fine. It will give you a scatter plot, but it will give you a scatter plot with ugly labels, meaning that you don't really have any control over the labels. It's going to give you pretty much your data frame and your variable as your labels. We maybe want to have something that's a little more sophisticated than that. So what we're going to do is we're going to also define the labels. So we can expand this command to actually add an X label and a Y label specification. So in this case, then we have plot housing.df median value against housing.df lower status, comma, X label equals, in quotes, median value, and Y label equals, in quotes, lower status. Okay. Remember that I said there are many ways to do the same thing? Well, I don't know if I said that or not, but I'll say it now. There are many ways to do the same thing. And that comes in the fact that there are packages that essentially have the same functionality built in. So you have stuff in base R that will give you pretty basic bare bones stuff. And when you see the plots out of base R, you'll see that it does the trick, but it's not pretty. When you get into some of these packages, you can specify a lot more settings, a lot more things like color, like translucency of data points, like the arrangement of how the plot is set up. It's much more advanced. But there are multiple packages that will do things in slightly different ways. So just get used to the fact that a lot of people have done a lot of similar things in a lot of different R packages. Anyway, we're going to take a look first at base R. This is what base R gave us, and it gave us ugly labels. And they are ugly labels. So all it did was give us the housing.df data frame name, followed by the variable that we picked. And it's black and white. Does the trick, tells us what we wanted to look at, and we can see, start to draw a conclusion, that the percentage of lower status residents is probably negatively correlated to the median value of the home, meaning that the higher the median value of the home, the less percentage of lower status residents live in that particular neighborhood. Okay? Let's look at it using the plots. Okay, so the plots now are the axes, I should say. The axes have now been better identified, so we have better labels. So now we said this is median value and this is lower status. That is done. Well, that's base R, and that's how we could do this in base R. Okay, but now we're going to do ggplot2, and ggplot2 is a different package, and it has different functions, and it's really kind of designed just for plots, for really good plots. So, and you look at the code for these, and the way you generate the plot is very different. So it's just a matter of getting used to what the actual functions are asking you to do. So we'll go ahead and I will cut over to R and I'll show you how to do this, but we'll install the package ggplot2. We've already installed that, actually. I've already installed that. I can do library ggplot2. ggplot, what it does is it looks at geomes, and these geomes are different types of plots. And so you'll see a geome underscore point, bar, histogram, box plot, all kinds of different plots that you can use and make plots with. Okay. So with ggplot2, you specify which type of geome or plot you want, and then you specify the aesthetic values. So at the very bottom there, I have a command, ggplot housing.df, that is our data frame, okay, plus, and this is how you determine what type of plot you're going to make. Geome underscore point is a scatter plot, okay, geome underscore bar would be a bar plot, etc. Then that is followed immediately by a function called AES, which is your aesthetic values. And this is where you set what it is you want your plot to look like. So your X label is going to be LStat, which is not in quotes. Your Y label is median value, not in quotes. Ironically, you close those out. Actually, after that, you have color equals navy, that is in quotes, which is, you never can predict what they're going to do in R. Followed by alpha equals 0.7. Alpha is a setting that allows you to determine how translucent or solid your data points are going to be, or your parts of your plot are going to be. That's all that is. It runs from 0 to 1. The higher the number, the more solid your data points will be. The lower the number, the more translucent they'll be, which is nice if you're laying data points of different color over data points of other colors. You'll be able to determine the difference. Okay. Let's go to the next slide. All right. I already told you most of this. ggplot is a plot function. We specify a geome underscore point, which is generate a scatter plot. The aesthetic values are X label, Y label. We determine the color, and we determine the translucency of our data points. And we'll get a more advanced plot. Let's cut over to R and actually do some of these things. Okay. So in our script, we've already viewed the data. I'm going to go back a little bit. We're going to actually do our first basic plot. There's our first basic plot that we did. And it was just the command that I had in the PowerPoint slide. And all I had was the data frame and the variables against each other. So again, we get the data frames and the variables as our axes. Close that one out. We go to the next command. We're going to adjust that plot to use labels. And there's our plot with our labels. Okay, it's the same plot, it's just got the label specified. All right. Now I have to load up library or ggplot. I have to use my library command to load up ggplot. I had already installed the package, so I know I have it on my PC. But every time I use it in a script, I have to load it with the library command. So that's what we're going to do next. And it is run and it is ready to go. Okay. So the next thing I'm going to do is it's now given me access, because this package has in it several functions. It's giving me access to a function called ggplot. And I'm going to be able to do something very similar to what I was doing in my earlier plots, using the same data frame, specifying the type of plot that I'm going to use, what are the aesthetic values, what is the color, and what is the alpha. There it is. So that looks a little nicer, right? We have colored spots, we have axes, we have a backdrop that looks a little better. It's a little more presentation friendly. So, and that's kind of what a lot of these plots are, is that they'll give you functions and features that you can add in that's not part of the Baseplot package. So it's kind of nice, looks better, okay? All right, so that's how we can do scatter plot. What we're going to do is break out and look at some other plots. And the first one we're going to look at is going to be the bar plot. Then we're going to look at the histogram. Then we'll look at box plots. And we'll look at, finally, finish up with some basic plots and some heat maps. So the first thing we're going to do is a bar plot. Now, a bar plot is like a bar chart, right? So what we're going to try to figure out is we want to know what is the average value of houses that are close to the Charles River versus the average value of houses that are not close to the Charles River. And so there's been some sort of differentiation that has been established. If you're close to the Charles River, your records get one value. And if you're close, or if you're far from the Charles River, your records get another value. And it's just been a 0 and a 1. A 0 and a 1 to assign if you're within 13 miles of the Charles River or not. I think that's the value that they used. So if we were going to do that in Excel, what we would have to look through is, what we'd have to do is look through the 506 records and identify all of the records that are indicated as being close to the river, and all of the records that are indicated as being far from the river, and we would have to count those up and separate those out. Then we would have to calculate the means for each of those. Then we would have to put that data into a plot in Excel and actually show a bar plot. So it's all stuff that we can do. It's all pretty easy. The nice thing about R is that R actually does some of this work for you. And so we're going to take a look at some of the commands, and I'll show you in Excel first, or I'm sorry, PowerPoint first. Okay, and this is basically the description that I just gave you. We're going to use median value, and we're going to use CHAS, which is short for the close proximity to the Charles River. That's separated out to 0 and 1. One indicates that it's close to the river, and the other one indicates that it's far from the river. So we have to determine each bucket that a record belongs into. So we separate all 506 records into either zeros or ones, depending on their proximity to the river. And we calculate the mean value for all the houses in each of those buckets, and then we plot the bars. Excel does this for us. I'm sorry, R does this for us when we put together a little more sophisticated code. So what we're going to do is we're going to identify a variable. We call it anything. In this particular case, we called it data for plot. And we set that value equal to the results of a function called aggregate. Aggregate is how we're separating out the zeros and the ones and putting them into each of the buckets. So we're taking all of the records and indicating which bucket they belong into. We're basing that decision accessing the variable median value, and we're asking it to separate by the value that is put into the variable CHAS, which is either 0 or 1. So it's basically looking at all of the records, grabbing my median value and saying, oh wait, you're a 0 in CHAS, so you go into one bucket. You're a 1 in CHAS, so you go into the other bucket. Okay. When it has finished separating out all of my median values and putting them in the appropriate bucket, it then runs a function called mean and calculates the mean. It calculates the average for bucket number 1 and bucket number 2. Okay. So let's take a look at what results from this particular data for plot. If we actually print out data for plot, what it's going to give us, it's going to give us groups. So, because we created groups, right? That's what the aggregate does, is it creates groups. And those groups were basically 0 and 1. Okay, 0 meaning that it's not close to the river, 1 meaning that it is close to the river. Okay, and it gives us 2 lines in our data frame here, the sort of temporary data frame I created. And it gives us the mean. So the mean, it's also, so basically what it's done is it's set us up. It's set us up with all the data that we would need in order to be able to build a bar chart. The only problem is we got ugly labels again. Group.1 is just a generic label that says here's the 2 groups that you had. When we looked at the Chaz variable, we could divide these into 2 groups, and that's what they were. And X is as generic as it gets because we didn't tell it what it was we were actually doing. So the next thing we're going to need to do is fix that problem. So there's another step that we're going to use to fix that problem. There's a names function. The names function is going to go in and it's going to identify the column heads for data for plot, and it's going to allow us to replace the column heads using a vector that we create. So remember, C is to create a vector. Vector has 2 parts. It has Chaz and it has mean, median, value. And those create or become a vector, which we then put into this function here for names data for plot. So essentially what it's doing is it's giving these column heads into that particular data frame. Now we're ready to build our bar plot. We have everything we need. So we can do bar plot data for plot using mean, median, value. The names argument is going to be data for plot, $Chaz, where your X label is Chaz, your Y label is your average median. Okay. So we have the bar plot, we have the name set up, and we have our label set up. Okay. We're going to get the averages from our data frame, build 2 bars, label them with the Chaz values, which is this part here, and then set the labels, and the ugly label problem is solved. Let's go take a look at this in R. Okay. Okay, here we are. We're going to set up the data frame. So we'll do that first. And that was where we just identified what goes into this data for plot. Remember, it's doing the aggregate command where it grabs all the ones, all the zeros, puts them into separate buckets, and then runs the mean, which is our function here, to calculate the average for each of the buckets. We'll go ahead and do that. And that is now done. If we did a print, we can see what our values are. Okay? And earlier I talked to you about hitting the up arrow. The up arrow allows you to go back to any command. Down arrow allows you to get out of any command once you've gone up. So that's a demonstration of that. Okay, so we have our data all set up, all ready to go for our plot, except the labels are ugly. So the next thing we're going to do is we're going to go ahead and set those labels by using the names command and feeding in a vector that we create. So that's done. Now let's take a look again. Oops, wrong place to go. And I can actually take advantage of the up arrow. Now we've got our data frame, and it's got Chaz, and it's got mean, median, value, and it's got the values that we need. The only thing left for us to do is to actually run our bar plot. And there's our bar plot. Okay, it's got the right labels. It's got the right both labels on the axes. Remember, we said that we wanted to feed it the names that came out of that Chaz value. That's where what those are, and it represents the values, the median value of homes that are either not close to the river or that are close to the river. Okay. So that was our bar plot. I'm in the wrong place here. Okay. There is another example in the book on page 64, I believe, that shows you how to do this in ggplot. And I'm not going to do it here in ggplot. I'm going to let you play around with it. When you go to ggplot, you're going to want to specify your geom as being geom_bar because you're doing a bar plot. Your aesthetics are going to be your labels. and your stat settings. Stat settings basically means make the bars truly representative of the values that are inside of them. In other words, the median values that are inside, both the ones that are close to the river and not close to the river. By setting your stat to identity, it will take on that characteristic and show that characteristic in the plot. The other plot example gives you the percentage of houses that fit into determined categories, so feel free to work with that one as well. But we're going to move on at this point, and we're going to go on to histograms. Okay, histograms, if you remember from statistics, histograms show distribution of values across a certain range, and it shows you how many of your records fall into each one of those bins. Okay, so we're going to do that. We're going to show histograms of the median value. And there's a base R1, and there's also a ggplot R1 that will allow you to see kind of different values and different variables. The base one looks like this, and it's pretty bare bones. It shows you frequency. It shows you the variable that we have down below that is being plotted on the horizontal axis, and it's just a histogram of housing.df $median value. Okay, we can see that we tend to have a lot of median value homes in the lower, like 10,000, 20,000, 30,000 sort of area. And then when we get to the higher median values, we really drop off, and we really don't have a lot of records in the data set that represent those. Okay. If we use the ggplot, we get a similar plot. Now, this is the basics of ggplot, and I didn't specify any specific aesthetics or anything that I really wanted on that. So it is looking like it's looking, but I have the ability to change colors and change translucency and all that other stuff in ggplot. So let's go over to R again and run through those. Okay, all right. Moving on to histograms. Simple base R histogram. This is the one I showed you earlier. And that's the bare bones one. And if I go on, let's get rid of this. ggplot one looks a little bit better. Okay. And the next plot I want to show you is a box plot. Now, a box plot is really representative of the distribution of data points. It will show you range, it will show you mean, it will show you bottom 25th percentile and top 75th percentile, and it will show you the distribution of data points that fall outside of that particular range. So box plots can actually be really useful. So we're going to take a look at those. And it allows us to sort of show comparisons of variables. We can look at multiple variables side by side. And this is really good for identifying outliers. When we have a data set where the average or the mean, even the median, can be a certain value, but it's actually pretty strongly impacted by the fact that we have outliers that are not really contributing to our data set. So we may choose to drop the outliers off and not use them at all. There are two commands there. One of them is base R package box plot, and I'll show you that. And the second one is the ggplot box plot, and I'll show you that one as well. Here's our base R one. This is the result of our base R, and it gives us, proximity to the Charles River. 0, remember, is not, they're not very close to the Charles River, so the average price of the house is lower. This is the top, or the 75th percentile and the 25th percentile. And this, starting down here at 0, or close to 0, all the way up to here is the typical range. And you do have some outliers there that are kind of throwing the numbers off. This is the ones that are close to the Charles River, actually, and you have a series of data records. The mean is actually higher, not terribly higher, but it's just slightly higher. Your range runs from down here around 15 all the way up to the 50s, and you have data points that fall into that range. So we can look at those side by side. The ggplot one, again, just it looks a little different. It gives you more features, so you can choose to use whichever one you want to use. Okay, let's go take a look at those at R. There's a simple base one, base R1. It's generated that way. And your ggplot generates that way. Okay. All right, we're going to move on to a different kind of plot, and that is a heat map. Heat maps are really useful for showing data in ranges. For example, if you were to use a heat map, you could show like values between 1 and 100. And if a value is at like 97, that would have a very intense color because it's very close to the end of the range. If it was down at 50, it might be much more faint. And if it was like down to 40 or 30 or 20 or something like that, it may take on actually a different color. It just depends on how you set it up. So the most common example of heat maps that I've worked with are positive values are green, negative values are red. And so the higher the positive value, the more green it is, and the lower the negative value, the more red it is. But there's various kinds of heat maps. It's just showing you by color, and it's easier to track by color what the values really are. So in this particular case, we have a very simple heat map. And this heat map is really just showing us correlations. So we're going to basically run a correlation comparison of every variable in our data set against every other variable in our data set. And because we're looking at everything, we don't really set any row values or column values. So it's a very simple one, and it will generate something that looks like this. And those colors actually indicate the extent to which the variables are correlated or not correlated. Now, if you look, there's a diagonal line going from the lower left to the upper right. That's because comparing a field with itself sort of is always going to be 1. So there's always going to be that when you do this correlation heat map. But the other squares show you kind of the level of correlation, and that color or the intensity of the color correlates to that level. So in R, very simple command. We have to load a new library for ggplots, or for gplots, I'm sorry. And then we run our heat map. And we can see the variables compared to each other and the colors representing sort of the intensity or the level of correlation. The things we can do with heat maps is, of course, we can put in the actual values in each one of the squares. We can change the colors. We can look at specific variables. We can look at specific things. But I just wanted to show you kind of the sort of base concept of the heat map. There are a few more, actually, that I'm not going to show you here. There are a few more plots that are in the PowerPoint presentation. They are base plots. And what base plots allow us to do, these come base R plots, and they just allow us to sort of look at our data set. And we can identify specific things we want to look at. So we can make a multi-dimensional plot using multiple variables. We can select variables and plot them against each other. We can specify variables by position name, all rows, but only columns like, for example, 1, 3, 12, and 13. And those represent those variables: crime, industry, lower status, and median value. And so we could run a simple plot. We're using the command there, plot housing.df, and we could look at, I'll just capture that, what that looks like in R. I'm going to go to the console for this one directly. And this is the base plot. So it shows crime, industry, lower status, median value. And we can see median value versus lower status, and we can see what that scatter plot looks like. We can see lower status versus industry, and look what that scatter plot looks like. We can look at crime versus industry and see what that scatter plot looks like. So that's given us some just basic scatter plots, some basic plot plots that allow us to look at multiple values at the same time. And you can specify whatever values you want, either by indicating the variable names or by, like I did in this example, you can indicate the position in the file. Okay? Remember that we said using square brackets, we're going to identify specific rows and columns. Because we use the column first, we specified all rows, or the comma first, we specified all rows, followed by a vector where I indicated that the columns I wanted was 1, 3, 12, and 13, and those just happen to equate to those variables. Okay. There's one other that I think might actually be even more useful. We can load a package called ggalley, and load that up actually using the library command once we've actually installed that package. And it gives us access to something called ggpairs. And ggpairs allows us to do a different kind of command, very similar to the one we just looked at, but it gives us more functionality and allows us to sort of see kind of a better comparison. So we'll grab that one. Cut over to R and plop that into the console. Oops. Oh, I haven't done ggpairs. Or what? ggalley. I didn't do ggalley. So it doesn't even know. That's what happens when you try to run a command that isn't there. Double up arrow, and then I can get what I need. Okay. I asked for those same variables: crime, industry, lower status, median value. Okay. Crime is correlated to industry, lower status, median value. You can see what those correlations look like. So you see each of the correlations. It gives you a line plot for the value for crime, and then it gives you a scatter plot that shows the two variables compared. So if you look at the over on the far right side, you see that industry versus crime is compared here, and that gives you that particular plot. And eventually you'll be able to see all of, as you work your way down, you'll be able to see all of the comparisons. You'll be able to see a line plot for each of the values, and you'll be able to see the correlation coefficients. That simple plot gives you all that in once. And so you can really use the ggpairs function to generate a plot and indicate whatever variables you want and whatever it is you want to see, and get whatever information you want. So by doing that, by doing this plot, or doing the histogram, or the scatter plot, or the bar plot, or the box plot, you can start to get an idea of what's going on in our file and what are we seeing in our file. And one of the things that might be the most interesting to us is if we start looking at lower status and we look at this plot right here. This is one of the first scatter plots that we did, but it included it in this ggpairs plot. And it tells us that we do have what seems to be a fairly stable negative correlation between lower status, the percentage of lower status citizens that live, financial status citizens that live in a particular region, and the median value of a house. That may be something that's actionable for us. We might also look at some of these. For example, if we were looking at crime rates and we're looking at the amount of industrial land, there doesn't seem to be much of a correlation there at all. If we're looking at crime rates and the percentage of lower status population, that's not looking that great either. So there's really not a whole lot of actionable information on some of these scatter plots. But again, if we run this for various different variables, we might find something interesting in the data set that is something we want to pursue. It's something that we want to actually take some action on. So, to recap, there are many, 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 many more plots. And so what I want you to do is play around with some of the code that's in the textbook. And throughout the course, we'll talk about which plot was going to be the best one to use for visualization. When we load a new data set, the first thing we want to look at, first thing we want to do is look at that data set and see what's in it. Before we start making decisions about what machine language algorithms or whatever kind of processing we're going to do on that file, we want to know what we're looking at. And we also want to know, is there anything we have to do to the file to fix it, because it's just not going to work the way it is. Okay, you have an assignment this week. Your assignment is this. You are going to load the Boston data, the Boston housing data, okay? And I want you to create 3 plots that are different from any of the ones that I have shown you in R or this PowerPoint presentation. So that's going to, maybe you're going to pull in different variables. Maybe you're going to use different colors if you want to use some of the more advanced plots like ggplot. But what I want to see is I want to see 3 that are different from anything I've showed you. It could be box plot, could be bar plot, could be whatever you want. Okay. If you have questions about the values or the variables or the arguments that you can specify on a particular function, remember you can use question mark followed by the function name. So you can do question mark followed by plot, and it will give you the manual the information about that particular function. Let's get there. We'll bring up the manual. You'll be able to see generic XY plotting. Here's information about the plot, and then it will tell you all of the different things that you can specify on that plot, like X label, Y label, things like that. So if you have any questions about any one of these functions that we've been looking at, question mark followed by the name of the function will take you to the manual, and you can learn more about that function. Or you can Google it. There's a ton of information out there about different R functions and different R packages, and so you'll be able to Google it and figure out what it is you want to do. With your 3 new plots, I also want you to provide me the code that you used to generate the plot and what information you think your plot provides to you. So what conclusions can you draw based on the information you're looking at in your plot? So submit the 3 plots and the code for each and an explanation as your assignment for this week. And just real quick, I'm going to go back to R. Get rid of this. Actually, no, I'll use this one. Any plot that you have, if you come to it, you can right-click on it, pull down to copy as bitmap, and then you can paste it into a Word document. So that's how you can turn in your 3 plots, is create them, copy them out of R, paste them into Word, follow that by the command you used to generate it, and any explanation as to what that data means to you. What is it telling you? Okay. So if you have any questions or any concerns about what we have gone over, we've gone over a lot. There's a lot to look at. Just give me an email, and I'm happy to walk you through or work you through anything that wasn't entirely clear. Great. Go to and have a great time with your plots.